everybody. So in this video, we're going to do composite functions with reflections. So remember, we work a composite function inside out. Work it inside out. And remember that a composite function is just more than one function that we're doing to a particular set of points. So here in this example, we have a reflection over the x-axis and a translation of 0 units to the right, or left rather, and then 4 units up because it's +4. And remember, zero is neither positive or negative, so nothing is happening to the left or the right. And then 4 units up because it's a +4. All right, so let me go ahead and gather my well, I got my points. My points are right here, 1, 5. I thought I was gonna have to go look for them, but they gave it to us. Hey there, 1, 5, 4, 1, and that's the pre-image. All right. So if you notice, you have the first one, A prime. We call that A prime, right? A prime, that's the intermediate. All right. So this is our intermediate point. All right, because this is not our final point. And then we got A double prime because it's the second operation. And that is going to be our, so A double prime, that's going to be our image, our final image, right? The final image points. I can spell final image points. All right, so let's go ahead and knock this out, okay? So here we go. Remember, we're going to work it inside out, and if you notice, they're using a circle here. So another way to write this without the circle, remember, reflection is a lowercase r, even though they're using a capital R there. They did write the x-axis there to let you know what it is. And you can write it with parentheses, right? So like this. All right. So you could write it with parentheses like that. Remember, you can have the XY in there, or you cannot have the XY in there. Either way, doesn't matter. Okay. So first, we're going to do the translation first, because that's on the inside. We're going to do that first. And then second, we're going to do the reflection over the x-axis. We're going to do that next. Okay. And actually, I should do that in green. Okay. So let's go. So that means we are going to do nothing to the x coordinates. The x coordinates stay the same because that 0 means we didn't do anything to it. But the y coordinates, we're going to add 4 to the y coordinates. We're going to add 4 to all the y coordinates. So 5 plus 4 is 9, 4 plus 4 is 8, and 1 plus 4 is 5. Okay? So those are my points that go here. 1, 9, 5, 8, and 4, 5. There you go. So now let's do our final operation, which is a reflection over the x-axis. Now, reflection over the x-axis rule says that the x's stay the same, but the y coordinates, we're going to multiply that by -1. We're going to multiply the y coordinates by -1. So, once again, the x coordinates stay the same, and we're going to multiply the y coordinates by -1. So 1, 5, and 4, and then multiply the y coordinates by -1. So 9 times -1, 8 times -1, and 5 times -1. So that's -9, -8, and -5. Okay, so those are my final image points. My final image points. So 1, -9, 5, -8, and 4, -5. Okay, so now it's time for me to graph the points. So I'm gonna take a moment, graph my final points only on this graph. So I'm gonna graph the A double prime so we can see what that looks like. All right, so there is the graph of my final image. Look at that, look at that, look at that. So we did it, y'all. We did it, we did it, we did it. All right, so that's what it looks like when you're finished with that problem. Let's go ahead to the next example. The next example is a blast from the past. We actually did this one before. But when we talked about it before, we just talked about it as a function rule and then how to do it over the line. I want to show you how this is also a composite function. All right. It is also a composite function. Remember, we're reflecting over the line x equals -1. All right. And we talked about how this composite rule, right, was the y coordinates stayed the same. But what changed was the distance, right? And if this distance was -1, that means it was twice that distance. So it was -2. And then we reflected the x coordinate. So our function rule was that. So let's look at this function rule. This function rule literally is telling us what to do. This negative means reflect over the x-axis. I mean, reflect over the line, that vertical line, right? So it's telling us to reflect, all right? And the -2 part tells us to translate 2 units. So it's actually a translation, 2 units left. So that's a composite function. So another way to really look at this then would be to look at this as 2 separate functions. So this is a translation, 2 units to the left, and we're doing nothing to the y coordinates. And then we're turning around and we're reflecting it. So that's a reflection over the y-axis. And you just have -x. So now you can see how this can also be rewritten as this. Okay, so this is the rewrite. All right, and that's a little advanced. If it makes sense to you, yay. And if it doesn't, that's okay. As long as you got this from the last video, you're gonna be fine. But I just wanted to show you that these are the same. This can be rewritten as a composite function. All right, thank you for your time. Good luck on your assignment.